Number 16 then from the 2013 Advanced Higher. This looks like your differential equation with separable parts to it. So we'll just start off and see what happens. First part is, take this and show you end up with this result. Well, that just means go through this integration. So what I'm going to have dp, this completely separates to this side, over p times 1000 minus p, and that will leave the dt on that side. Then immediately I can see that if I'm going to be integrating this, I'm going to be using partial fractions to separate that denominator. So I'll do that part to the side. So let's just do these partial fractions. So let this thing, 1 over p times 1000 minus p, equal a over that part and b over the other linear denominator. In which case, a times 1000 minus p plus b times the p should equal 1, just multiplying through it by the denominator there. And then you can just use some knockout values here. So if you let p equals 0, you'll knock out this term and leave you with 1000 a equals 1. So a is 1000th, a bit annoying. Let p equal 1000, knock out that part, and then 1000 b will also equal 1. So b is also 1000. Well, that's not so bad because at least they share that disability. So altogether this is going to become then, you might as well just keep that out as a factor. So 1000th of 1 over p plus 1 over 1000 minus p. That'd be a neater way of writing that. So back to this then. This can be replaced by that. So what I've got is 1000th of 1 over p plus 1 over 1000 minus p dp equals dt, and then we can integrate that. So let's just pop that wee integration sign in. Whilst I'm at it, I'll just take that across and make it 1000 times that side. So this part's going to go back to the logs. So what I'll have here is log of p. Now p is not going to be negative, so that term's fine. This is going to be log of 1000 minus p in this part. Now the derivative of that linear part there is -1, so it's going to be minus that. And again, going by this model here, that would suggest that when p reaches 1000, this term comes to 0, so there'll be no population growth. So that p at 1000 would be the maximum anyway. So again, I'm not supposing that this is going to turn negative on me. And that should equal 1000 times this side. And at the same time, we'll just integrate that dt back up to the full t plus a c. So that's what I've got so far. And then the last part would be, join those logarithms. So it'll be p over 1000 minus p would equal 1000t plus c. And that's your first 4 marks. Now you just have to tidy this up a bit so it just reads p equals. So here we are, back up here for some space. So first step will be, let's get rid of that log. So p over 1000 minus p will be e to the power 1000t plus c. And of course, those powers can be split into the original 2 factors. That can split into 1000t times e to the c. Now there's no reason for not just calling this part c again, but they want to call it k. So here we're going to say let k equal e to the c, since they've decided to use a different letter. So what I've got now is p over 1000 minus p is k e to the 1000t. 2 mentions of p here. I'll need to separate them before I can put them back together. So taking that across and multiplying this side would be 1000 of them. Now I know they're factors, but I need to split them afterwards anyway. 1000 of those minus p times this. So that's that denominator taken across and multiplied. Now you can bring that p over to join that p. At the same time, since it's going to be that plus this term, I'll factorise it as well. So there's the 1 for the one that was there already. Here's the plus for it coming over, and here's the part that was left. Ke to the 1000t. That should equal 1000 Ke to the 1000t. To be left with p, take that across and divide. So p is going to equal 1000 k e to the 1000t divided by 1 plus k e to the 1000t. And I suppose at which point should I have indicated that this was a function of t, because it's got that in that solution. Maybe I'll just pop it in here. That's a bit cowardly because I can't be bothered putting all these brackets in there. Then the last part is, now that's not quite the same as the solution, but that is a fraction. And you can do what you like to the top and bottom of a fraction within the realms of decency. So in this case, what I'm going to do is divide the top and the bottom by e to the 1000t. If you divide the top by e to the 1000t, I'll be left with 1000k. If I divide this by e to the 1000t, I'll be left with k. And if I divide that by e to the 1000t, I'll have 1 over it, which is e to the negative 1000t. Now, I suppose I should explain how I got that. I know I've just explained it, I mean to whoever's marking it, so I suppose I could put a note at the side, and that was divide by e to the 1000t. And that's the result. Last part says, given that p0 is 200, that means when the population is 200, you're calling that the starting time times 0, rather than 200 organisms spontaneously appearing. Determine at what time the population will reach 900. That'll be time after the start. So I'm looking for the time to make 900. Well, the first thing obviously here would be pop those numbers in to establish what that constant is. I'll do that over here. So the population was 200 at time 0, so it'll be 1000k over k plus e to the negative, and that'll just be 0, so I'll just put 0. So that's just the same as 1. So if I take that across, I've got 200k plus 200 equals 1000k. That was just k plus 1. I'll bring that over to that side. I've got 800k equals 200. So there's my constant. K equals a quarter. So I think I'll just put the quarter in rather than taking that down to 250, because I'm going to have these quarters in the denominator as well, which I don't want. So multiplying everything by 4, I've actually got the formula p of t equals 1000 over 1 plus 4e to the negative 1000t. So if it says how long does it take to get to 900, I want to find t, so the answer is 900. So I'll have 900 equals 1000 over 4e to the negative 1000t to solve. Take that up there. So it'll be 900 times both of those. 900 plus, and that'll be 3600 e to the negative 1000t should equal 1000. Take that across and subtract, and that'll just leave me 100. So 3600 e to the negative 1000t will just be 100. So e to the negative 1000t, you know I could have skipped some steps. We'll take that across and divide, that'll be 1 over 36. So that negative 1000t, or I could just have flipped that there, because if that's the case, then so is the reciprocal of it, which is e to the 1000t should be 36. But I started there anyway. Equals ln of 1 over 36. So t would be ln 1 upon 36 over negative 1000, which is of course the same as that, because that's going to give you 1000t is ln 36, so t is ln 36 over 1000. They're both the same expression. That's a better one though, because the negative there could be brought up here to apply it to the log, and then brought within the log as a power negative 1, which would then reciprocalify that 36. Now it's just a case of, will that do, or will we need to press some buttons? And you press the buttons and you get 10 to the negative 3, that's 0.00358, etc. And then you begin to think, how can that possibly be? Because you were assuming maybe t, well I'm assuming maybe t was in years or something like that for some population, and this seems to be a tiny amount of time later that it would get from 200 up to 900. However, putting that back into the equation does give 900, so that certainly is the answer that solves that. Whatever the interpretation of it is, that's a different matter. There's no stipulation about what T stands for. Now, that is the question finished. That is the answer. Well, I get anyway to that. I'm just annoyed by that answer, but then I'm just considering, if you look back at that equation, then what that says is the rate of change of the population with respect to time is given by this feature here of the population itself. Now that's an upside down parabola, so it's looking at that part, it would be like this, where that's the rate of growth of the population. So that would imply from that the rate of growth will be 0 when it hits 1,000, so it stops dead, and its maximum rate of growth will be up here around about 500. But more than that, what about the actual values of them? Because here when it said something like, when the population was 2,000, well, how fast was it growing? Sorry, 200. How fast was this population growing at 200? Well, that should be, according to this formula, 200 times 1,000 minus 200, that's 200 times 800. That's 16 with 4 zeros. That's 160,000 biological units, whatever they are, per unit of time. And that can't possibly be right if the time is meant to be just not like minutes or years. It must be that this time interval, whatever T stands for, is some huge amount, like the lifetime of the ecosystem, the lifetime of the planet. I do not know. I just know that this is a very unsatisfactory answer here, but it is the answer to that equation.